Next, we are going to solve an ordinary differential equation. Here I am going to show you the steps of the solution, because it's a kind of method how to solve this kind of ordinary differential equations, but we are going to solve only first order and only one equation. So if we have got a second order system, we have got two first order ordinary differential equations. If we have got a third order system, we will have three first order differential equations. So it means that if we have got higher order systems, we usually have a system of ordinary differential equations, but all the equations are first order. So now I would like to show you only one first order differential equation, how to solve it, because there are some definitions that we have to mention. So let's say about v dot is equal to b over mv plus 1 over mf. This is the equation of the cruise model that we have solved before. So let's say m is equal to 1000 kilograms. This is the mass of the car, for example, and the constant b is equal to 50 newton seconds per meter. By this, we are going to get this problem. V dot is equal to minus 0.05 V plus 0.001 F. So F is the input of the system. F is 0 if the time is negative, and a given value F0 if the time is 0 and positive. So F0 is constant. So now the question is, what is the v of t function? So what is the velocity function which corresponds to this ordinary differential equation? So please remember that the solution of an ODE is usually a time function. And there is an initial condition which I put to here. This is v at 0, which is 0. We usually need an initial condition. So now if the time is 0, the velocity of the vehicle is 0. It's a normal initial condition. So how to solve this problem? In the following videos, I am going to show you step by step of the solution of the ODE, and we are going to speak about the details. So we prepare 5 short videos, because every steps I would like to mention in different videos. So first of all, this is the solution. V of t has two parts. V index tr of t plus V index st of t. So the solution of the velocity has got two parts. The first part with the index tr is called the transient solution, and the second part with the index st is called the stationary solution. So the problem has two parts, transient part and stationary part. So the transient and stationary is important because we are going to use these words later many times. But what is transient and what is stationary? At the last step, we are going to draw v of t, and there I am going to show you in a graph what is the transient and what is the stationary. But now we have to define them as follows. The transient solution is the general solution of the homogeneous differential equation, and the stationary part is one particular solution of the non-homogeneous differential equation. So the transient is a general solution. The stationary solution is one particular solution. The transient solution is the solution of the homogeneous equation, And a stationary solution is the solution of the non-homogeneous equation. But what is homogeneous and what is non-homogeneous? So I put the two equations to here. A differential equation is homogeneous. There is no other time function, just the v. Now the v, because this is the variable for us now. So if you have got the equation of v dot is equal to a constant and multiplied by v, this is the homogeneous equation because there is no input, there is no f in this case. For this equation, we usually have a general solution. This will be the first one that we are going to speak about. And why general, I am going to define it in the next video. The second, as you can see, there is v dot equal to minus 0.05 v plus the input 0.001 f0. And in this case, the time is non-negative. This is the non-homogeneous equation because there is not only v, but v and the input, and now the input is f0. So this is the difference between the homogeneous equation and the non-homogeneous equation. And there will be only one particular solution of the non-homogeneous equation. Please remember that the homogeneous equation has general solution. It means that there are infinite solutions. But for the stationary, we will have only one particular solution. So in the next videos, we are going to speak about the transient part, the stationary part. We are going to sum these two together, and we have to work with the initial condition too. And finally, we can draw the solution, and we can write the equation, the time function of v of